9 o'clock. It's time to do some coding. Time to turn this goddamn awful lift music off. Hold on a second, it's coming. Oh, phew, there we go. Let's just put on some chill here. Hey, I'm wearing white today to try and camouflage myself against the screen because I'm dreading this topic because I am not in the slightest bit confident. Really haven't done my homework at all. I've got a basic idea of what the old Dijkstra, I can't even say it or type it. There it is. The Dijkstra pathfinding algorithm. Ooh, that's cool. Look, new YouTube clip. I got the idea though. I get the concept. Ooh, is that working? Yeah. So I just need to work out how the heck I can apply it to our game. So let's take a look. Oh, and before I forget, I did promise to send someone an email. And his email address is down here. Where is it? Here it is. And I will just ping him an email from here and say, here's my email address. Right. Come to Discord and let's have a chat about what you like to do. All right, there we go. Enough emailing while I'm live on stream. So, Dijkstra. Who is Dijkstra? Tell me about Dijkstra. What a guy. Who is Dijkstra? Dijkstra's algorithm. There we go. Putting in my advertising for Tesco's orange juice. So, where are we? A little bit about the person before I look at the algorithm. There it is. 1956. Good Lord. This guy was a pioneer. Pioneer in computing science. Theoretical physicist by training. Makes sense. So, yeah, you can see this little animated diagram here. In fact, if I just open that up in a new tab, and open that image in a new tab, and zoom right in there, we can see exactly what's going on here. So, 0 is where we're starting. So we're starting at point 1, and I'm pointing, yeah, there we go. So we're starting at point 1, and to move to point, this is totally backwards on my screen, move to point 2, 7 units, right? I'll just use the pointer. So that's a very, well, that's going to take 7 whatever units, miles, minutes, whatever, to get to 2. To get to 6, it's going to take 14, and so on. So what's the fastest route to 2? Well, this would be 9 plus 10, which would be 19. Then you've got 14, 15, 16. Yeah, so it's definitely going to be just straight A to B. That's the quickest route. Anyway, so you from one node, you work out the distance to every node in your network. And from there, because you're calculating these numbers, which start off as infinite, which is the highest number possible, and then they slowly reduce, you can see which the lowest number on the network is going to be the quickest route. So, in this case, I'm not sure what the we're going from A to B here, right? So here, yeah, we're seeing all the different. It's trying the different routes here. It's going. Shall I go here first? That's 7. If I go here, that's 9. If I go here, that's a 14. So that's that one done. Now we'll look at this one. So 2 to go here is 10. To go here is 22. And it's including the 7 that it's already got, right? So then we look at the next node, 3. So here's here, and here is here, and so on. And these numbers are accumulating until eventually we hit B. So we can see from that our quickest route is 1, 3, 6, 5. So we're following the lowest number. Yeah, we're from each time we make a jump. Oh, is that true? No, it isn't. I haven't got to the next bit yet. Let's get to the next bit. So I was going to try and do this first. So I found this on, what's it, coding game? Yeah. Coding game. There we go. Dijkstra's algorithm. I got to page 2 here. Page 1 was pretty easy. I'll just go back to it, just in case you haven't looked at it before. Oops. So page 1 is just really just checking we have this concept of what's what on the node. So the first question it asks us is, what is the weight of the shortest path between C and E? So we add all the numbers up. The shortest path between C and E is A, B, E. Right? Because that's 1 plus 3 plus 1. Because I spent ages looking at it going, surely it's fastest this way. Ooh. So 5 is the weight. 1 plus 3 plus 4. Sorry, 1 plus 3 plus 1. So I managed to get that one done. Super duper. So now we get into the nitty-gritty here. So during the algorithm execution, we'll mark every node with its minimum distance to node C, our selected node. So I think we need a little bit more complexity in our network, but we have got some complexity. We've got an elevator that takes us up to R&D, but we haven't got the sort of complexity that would allow us to see this sort of thing yet. But I think we could certainly add it. So what we want to end up with, ultimately, are end result. What do we want? Honestly, one of the best things you can do, coding, marketing, any sort of development, is just really identify what your end goal is. If you do that, it makes the path to the solution so much easier. So we can see we've got locations, right? Nope, you can't see that. There we go. So we've got our locations here and here and here and here. And if we go and look at our character script, you can see Graham, for example, has this list of paths. And I think that's what we want as our end result. We want to know, we want location 1, comma, location 2, comma, so on. Right? Oops, you can't see me drawing. I've got to sort this out. Location 4, etc. And we want that to be an array. So where this is our start and this is our end. Then we've defined some sort of pathing algorithm. Once we've got that sorted out, we can create pathing which doesn't just have to indicate like connected locations. It can connect, like, it can say go from A to D to Y, and the guy's going to use all the locations in between to make their way through that path. And that's ultimately we want a little bit more intelligent pathing for our character. So Oops, stream. Right. So if we know our end result, is it going to help us? Well, I've still got to work out how this works. So during the algorithm execution, we'll mark every node with its minimum distance to node C. Our minimum distance in our case is always going to be 1, although we could weight it. Why don't we weight it? Let's do this. I don't know how we do it. I think we probably weight the exits. So how long does it take the character to get to the left? How long does it take the character to pass through the corridor? Maybe the weighting has a direct influence on the speed or the time the character's in a location. Be interesting. And the state of the character. We could have a character running, right? Really got to get around this sort of footsteps thing. It's a bit of a pain in the ass at the moment. Okay, well, we won't worry about that too much at the moment. Let's just imagine we've got a weight of 1. Will we? Yeah, I think weights of 1 will do for now. Okay, excuse me, fizzy drink. Okay. So, during the algorithm execution, we'll mark every node with minimum distance. For node C, this distance is 0. Great. So the target, first place we have is 0. That's our starting point. For the rest of the nodes, we don't know what the minimum distance is. It starts being infinity. So it makes sense. If we're trying to get the longest route to a place and we don't know what it is, the shortest distance, marking them with infinity means that we need to check those. We'll also have a current node. Initially, we set it to C, our selected node. In the image, we mark the current node with a red dot. Why? Now we check the neighbors of our current node, A, B, and D, in no specific order. Let's begin with B. Okay, so I am going to start writing some pseudocode here as we talk about how this will work. So where am I going to put this? I'm going to put it in character. So we'll create a function called pathfind, and pathfind is going to have a from location and a to location. Now, what sort of variables are they? They nodes. Should we do them as nodes? I think so. I think that makes sense. These are node paths, right? Yeah, we have target location, which is a node path. Let's just have a look at our script here. Yeah, export node path of our target location. So yeah, we'll have a node path. How do we define the node path in there? I just saw one bit do it, and I totally forgot what he did. I think it was that. Yeah, maybe. No, probably not. It's gone blue. It doesn't look good. I've done it somewhere before. There he is. Colon. All right. Node path. This one's also a node path. And what's it going to return? Well, that's our end result. So we want to get back an array. Can we do it like that? What do you think, Godot? No. A non-void function must return a value, of course. Right, return, we'll call it final path. And we'll set it up. It isn't declared yet. Yeah, so we'll... Now, should we define the path as a variable for the character? I think so. I think we always want to be setting this variable for the character. So, don't know if I want that accessible. I don't think so. I'm going to set it as we'll start using private public variables. So we'll call this underscore current path. Now we do have a path at the moment, right? Should it be the same thing? No, it isn't the same, is it? Path is the route we want them to take. So path might be our overall, like from here to here to here, but this is our route, right? So let's call it path route, something like that. It's an array, and this is the this is set by our pathfinding algorithm. Likely. We'll see if I can manage to get it to do that. What's wrong with that? Error passing expression, misplaced built-in type. Oh, yeah, that's not right. It's not equals array. It's just var array. Path route? No. Path route colon array. Yeah, here we go. Okay, super. We'll come back to that then. Oh, you can define it like that as well, right? I'd prefer that, to be honest. Just an empty path. Oh, is that? Yeah, that is a... It's not a dictionary, is it? I can... Final path... Oh, right, okay. Okay. So, final path is now... Oh, I've forgotten the name already. Path route. Super. Right, so step one. Check. So we need to loop through all. We want to create a whole network of. We want to create a list of every node, right? And then we want to work through it, crossing them off. So. So we'll start off by creating an array of all our locations. So, all locations. So we'll create a list of all locations, which we will work our way through. Okay. Then, what was it saying? The next thing we need to do is, so for each location, check for exits, loop through exits to other locations. And increment. So this list of all locations we want to work our way through are all going to have, so this is actually going to be a dictionary file, right? So it's going to be a bit like, this, right? Location 1. Let's say that's where we start, right? And location 2, infinity. Location 3, infinity, right? And we're going to go through this list of locations where we want to find out the actual value. It won't be infinity anymore. We're going to update it with so distance from location 1. Create a list of all locations starting with our current location, right? Do we need to do it like that? I think I don't know what, we don't really necessarily need to do it like that, but we'll work our way through all locations, calculating distance from start, from distance from, let's call it start location rather than from location, right? So it should be start and end, right? Not to. Okay. Okay. Through all locations, calculating distance from start location. Right. Okie dokie. Okay. So for each location, loop through exits to other locations and increment distance values in all location dict. Super duper. All right. So let's check something here. Okay. All right, back to the old algorithm. So we've got a starting location. Now we check the neighbors of our current location. So that's fine because we're checking the exits for our starting location. And then we're working our way. Why do we go to A next? At the minimum distance to the current node with the weight edge that connects our current node with B. The minimum distance of B. That's fair. It does seem like we're working our way through neighbors, but we don't necessarily. I don't know if it really matters which neighbor we do, right? We've checked all the neighbors as C. Because of that, we mark it as visited. Ah. I see. So we have a current node. Let me just go back here. Oh, I see. Right. Okay. Yeah. That makes sense. Okay. So, so for each location, call it current node, right? Okay. Makes sense. Okay, so we increment, so we're looping through our neighbors. Yeah, so we are looping through. We're not looping through each location. Oh, we are. Okay, we're looping through each location, but we're also looping through exits. So that's our current node, right? Which is the location. That sounds like it'll work. Okay, afterwards we mark A as visited and pick a new current node, D. Yeah, it's a non-visited node. How do we know if we'd visited the node or not? I suppose we don't need to worry about that because we need to store some value against it to say whether it's visited or not, because we're looping through them, right? I know we might need to. Okay, right, so we obtain, for B, we obtain 2 plus 5, so that's this and this. Compare that value with B's minimum distance, 4, and leave the smallest value, 4. Right, I see. If it was smaller, is that obviously that's 7. If it was smaller than 4, we'd update the value. So and only increment the distance value if the value is smaller than the current value, right? So we say infinity. We could represent infinity with like something ridiculous, right? Yeah. So that way we're going through and we're updating this to the most efficient route possible. We mark D as visited and set our current node to B. Almost there. We only need to check E. That's our last target node. 4 plus 1 equals 5. So we're on 4. We add 1, and that's 5, which is less than E's minimum distance, 9. So we'll leave the 5. So there we go. We cross out the 9, stick 5 in. Now we mark E as the current node. E doesn't have any non-visited neighbors, so we don't need to check anything. We mark it as visited. So we do need to know. We do need to know in our loop. I know we're stepping through all the locations. I don't know how we're going to represent that in code, but I think it's about to try and teach us. As there are not unvisited nodes, and not univisited nodes, we're done. The minimum distance for each node actually represents the minimum distance from that node to C. So obviously the route will be the lowest route, so it'd be 1. And then it's going to go, there's only really one route here, 4. And then there's E.
You learn Dijkstra. Laughing smiley.
I'm working on it. I'm trying. I love the way she pronounces it, Dijkstra. Dijkstra, right? I think. Thanks for joining the stream. Have you done this before?
Can I help you?
Oh, well, maybe. It's a bit weird. I'll show you the way I'm doing it at the moment. So I have a load of locations here. Location nodes. And each location has an exit to another location. Right? So I've got means of checking and to see whether I can move to a given location or not. So there's no waiting in my case. Every path here is 1. So really, I think the trickiest thing I've got here is working out how I want to represent this. So I'm going to create a list of all my locations, and I'm going to loop through each location. I'm going to loop through all locations, and for each location, I'm going to go through the exits. So my living area here has an exit to the study, the balcony, and the lift. So I'm going to look at those, and they're all going to be 1, 1, and so on. So I've got 3 exits there, and then I'm only going to increment the distance value in my dictionary if the value is smaller than the current value. So I'm setting the current value to like 9999999 instead of infinity. And I've got to turn down this music. It's really loud. Jeez. So that's all. That's where I'm at the moment. So I want to return an array of paths. So I just want to have location 1 as my starting point, and the array will have here the locations in between, and then my end location. My end location at the end. So that's all I want to get out of the algorithm. So I'm just getting to the end here, where it says, here's a description of your algorithm. Mark your selected initial node with the current distance 0 and the rest with infinity. So that's kind of what I've said here. Location 1 will have 0. Location 2, 3, and 4, etc. will have 9999. I'm just pseudocoding at the moment. Oh my god, I've forgotten which node. Well, there we go. For the non-visited node with the smallest current distance, the current set the non-visited node.
You have a starting node where you begin.
Yeah, so I'm passing into my function here start location and end location, and they're going to be node paths. So if I start in the living area, I'll just show you really how it works at the moment. So here I am in the living area.
Up the distances to the neighbors.
Yeah, so all my neighbors here.
Sorry for my bad English.
Your English is perfect. It's just the lady that's pronouncing it is pretty bad. So here I am in the living area, so I can go to the balcony. That's just one. All right, go back into the living area. I mean, basically a living area with a load of other locations around it. The only long route is this lift. I'm going to the lift. Now in the lift. And then I've got these buttons, which basically take me up to... Oh, hello, Mr. AI. I'm going to take her up with me to R&D. There we go. Now we're in R&D and I can't exit this. So, yeah, so if I could do that, path from the study to the R&D department, that'd be fabulous. So it'd look a little bit like... I might as well draw it out so I can get an idea of what I'm doing here. Living area, study, balcony, lift, lift, second floor, first floor, R and D. So I want to go from the living area here to R&D, for example. And these are all going to be 1, 1, 1, 1, and 1. So, I mean, it's not a great example, really, to test this algorithm with, but it doesn't really matter. I could always add some extra nodes on and we can test it thoroughly. So, this is where I'm getting stuck. For each neighbor n of your current node, C, at the current distance of C with the weight of the edge connecting C minus...
You add the way from L to lift and then from lift to the other node.
Yeah, exactly. So how do I store that? Like what I'm thinking is a dictionary, but I don't know if that makes any sense. If it was JavaScript, I'd declare an object
Int
here.
Variable.
An int variable.
Variable.
Yeah. It sounds like you're shouting at me. Yeah, okay, so that's a variable. That's no problem. But I'm just wondering how I store the overall thing. So let's say Godot dictionary. Oh, in fact, let me just like work this out. So I want to store a location, right? I want to store the...
Make an object which stores the distance and do an list.
Okay. Wait, do I just make a new object, a completely new object for... Okay. Yeah, right, of course. You know, I've got to start thinking like this, because in JavaScript, I would have created
then
an object.
Then you iterate about the list.
Right, but in this, I've got to create like an actual... so I create a new script, right? Is that what you're saying? So we'll call it... what should we call it? Root object? Routing? Something like that. Routing. Oops. I'm using capital letters. Okay. Does it need to be a node, or is that all right? So I'll give it a class name of routing. And I'm going to give it a variable of... does it need to store the location name then? Like this?
Yes.
Cool. Okay, and then I just instantiate a load of these objects based on
You have to
location.
check if you visited the node.
Oh, right. Okay. Yeah. Okay. Thank you, man. That's awesome. That is the ticket. Right. Cool. You know what? You're opening up potential here of like just general programming potential. Okay, cool. Right.
For this reason, you could check the string, which stores the name.
Okay. Yeah, I could. Oh, I could just set this as a bool, right? I like having it clarified nice, because I'll probably use location name later, which would be, in fact, location name could be my node path, right? Could it? Oops, declared that wrong. Maybe. Maybe not. I'd rather get a list of location strings and distance and integer.
Class node, name and distance as variables.
Class, node, name, and distance. Oh, you mean I don't need location name, I just need name? Is that what you're saying? Oh, it already exists. Do I just not need that? I'm not sure what you're saying there. Class node, class, or class node? Class
You
name?
look the way from living area equals.
You look the way from living area. Oh, you know what? Oh, Christ, I'm not even sharing my screen. I just realized. There we go. So, like that. Oops. How's that? Or root node or something.
Yeah.
Yeah?
Log
All right.
scoof.
Nice.
Good. Looks.
Nice. Okay, cool. All right. Root node. Root. I've been not putting spaces in my class names, which is not very good, I suppose. Should be like that, right? I don't know with it. Does your file name need to match your class name? And there's a case sensitive. I've not done this properly yet. Actually, I might have done, kind of. No, I use objects in the tree. I never really.
I only know you have a laughing smiley.
Well, that's honestly such a good language to know to jump into this. I've just been developing websites for so long. My head's not in this. It's actually really cool. Just being able to expand the problem solving, like when it comes to games development, is like intense. It's absolutely awesome. Software development is just in general for like apps and things. It gets a little. It kind of you lose that creativity, I think. Doing the same thing all the time. So okay, right. So I'm going to try and instance a class of root node in my loop and create a list of an array of these objects. Is that what you said? Let's have a look.
Should I try to explain the algorithm as easy as possible?
Well, I think I get it. I mean, that's it basically, right? Mark your initial. I mean, I get the algorithm. It's just storing the information before I launch on it. So now I've got this object of root. I know what I need to do. I need to create a load of these for each location. I'll initialize the distance with something huge. Visited will be false. In fact, can I set this here to like false rather than bool? Distance will be, yeah. Root node already exists at path root node. All right, what's going on there? Let's just close that. Open it back up again. All right, happy? Happy. So now I've got to instantiate and how the heck do I do that? I think I did it when I created a load of buttons. What did I do? It's not player. Game. Update queuing. Instance.
After you make the instances of the objects, you have to build the relationships.
Yep. So how do I create the instance of the object? That's what I'm wondering. Is it just new? You know what? I'm sure I did this the other day, and it just, because I'm only doing an hour a day, it goes pretty fast at the moment.
var obj equals class underscore name dot new.
Nice, thanks, man. All right, okay, so let's try that. So I'll just test it first. Spit something out. So var obj equals root node dot new. Thing is, root node can't be loaded yet, right? Because we haven't loaded it. There's a loading thing, isn't there? You have to do. Yeah, this is ringing bells. Finding files. Load. Load JSON. Yeah, right. So rather than that, you do load, and then you can just pull in.
If you use class underscore name, no need to load.
Oh, right, cool. Is that so? That's awesome. Class underscore root node. That's not working. There's no relationship to my class anyway. I'm not loading it anywhere. How would it know? I have to add it to the tree? Or...
I think the name was just root underscore node.
I see what you're saying. So, okay. Right, well, that's what I just tried, I think. So what, without the word class? Like that. So then I get the class root node couldn't be fully loaded.
Yes.
Script error or cyclic dependency. I had this problem before, so I ended up using load. What do you think? I'll Google it. It'd be good to know. Couldn't be fully loaded. Cyclic dependency. There it is.
Sometimes it happens. If it doesn't work, then just use load.
Well, that is pretty much the story of my coding. It's cyclic dependency. Very easy to make cycles when using class name as types. Why is referencing each other's class types causing inheritance issues? Oh, right, okay. Is it something to do with the parent of my root node? Like, do I just actually not extend anything? Because I don't need to extend node, right? That should be it. Come on. Let me just reload the project. All right, scripts, controller, and character. Hey. I'll just type it in again.
You need to extend from node if you need to add the object to your scene tree.
Well, do I need to add it to the scene tree? Because I'm just using it for processing here, right? Because all I'm going to do at the end of this function is output a path route. So I think I can just say obj.distance equals 10 now, right? And it'll be happy, print obj.distance. Should we try it out? Let's try that out. The only trouble I'm going to have with is like defining this path stuff. You know what? I'm just going to make this a string for now. capital S.
I wish you a lot of fun. I am going to sleep.
Thanks. Look, you know what? Thank you so much for your help. That's much appreciated. Have a good sleep. And if I catch you again, I owe you. Cheers. I'm going to put you in the contributors list.
Do you stream often?
Every day at 9 p.m. And I'm going to put you in the contribution list. Thank you very much for contributing, helping out. It's really useful. So I'm just going to stick you down here in our little list. There we go. I'll put pathfinding. Thank you, dude. Cool. All right.
If you don't use extend specifically, it will automatically extend object.
Oh, okay. Oh, that's handy. So it'll still work. Oh, I see. Object. Right. I've not even looked at the object class. But that makes sense. That, you know what? I'm going to use that so much right now. I wish I'd known that right from the start. It would have made, I would have a completely different structure right now.
Another look on things helps so much, in my opinion.
Oh, definitely. Honestly, streaming has just made it so much easier for me to learn. I think it's fantastic. So, and thank you so much. How do you pronounce your name? Oh, Whitcowslan? Whitcowslan. Why? Silent T? You're not going to be able to tell me how to pronounce it, are you? Not with this voice thing.
It is German laughing smiley.
I will find out. If you come on the stream again, I'll get the pronunciation right, don't you worry. Do you watch the other streamer, Fighton? Is it Fighton? Yeah, Fighton 12. If you haven't, check him out. He's English-German coding. He's doing a 3D PvP fantasy game development series. So, again, awesome dudes. It's quite a good stream. I've watched it, even though I don't understand a lot of what's said. The code is all in English, which is pretty handy. Most of it. Oh, cool. What's this? Thanks, man. You're the first person in my list to follow me. Cheers. So I'm going to try this Pathfind right now and see if I get something.
I am always envious on people who program games.
It sounds like you can program games already. You just choose not to, right? Oh, is that what, for a full-time job? Because that isn't me. Yay! Look, I'm getting 10, 10, 10, 10. So that works. Thanks,
No,
man.
I am a student.
Cool. Oh, well, it's exciting. It's like, I loved being a student. It's like being in an RPG where you're leveling up and preparing to choose your speciality. It's the most exciting stage in life, man. I'm stuck now. So I'm doing games programming as a 43-year-old. And I'm doing the route that I didn't take. Not planning to do it for long, though. Just want to complete this. That's my main thing.
Yeah, sure, but with a lots of tears.
Yeah, totally. Yeah, I have nice... don't have any drama in my life. Well, not much. Right. Oh, man, that's so cool. So now I've got to create an array of objects. What if that's going to work? Append, right? Append.
I can only program console programs.
Console programs? Well, I don't know what you mean. Console programs? Well,
We learned the algorithm at the university.
Oh, right, okay. What are you using at the university? What languages are you using?
Without an GUI.
Oh, jeez. That's all right. I mean, yeah, most of the coding I do doesn't have a GUI. This is a pleasure, though. It's quite nice to have a GUI. Although, look at the stuff I'm doing. I'm not doing anything 2D or 3D, really. But that's because I'm not used to it. Every other Godot programmer seems to be doing 2D or 3D, and
Actually, we learn in Java.
Oh, cool. Oh, yeah, you said, yeah. Well, Java's amazing. And plus, it's like your entry point into C#, right? So you've got two of the
SQL.
Oh, even better. I mean, that's, if you can do databases, then you're laughing. Are you doing software then? Software engineering? Something like that. My test here is to see if...
Why do I hear explosions, dragons and screaming?
It's not from my stream. It must be someone else's. Right, so now I should get 12, I think. Yeah. So I'm just checking to see if I'm storing a location of distance, storing an array of location objects, and then I'm printing out.
I will have a look on your stream, but I have to sleep now.
All right. Sweet dreams. Have a good night. Take care, and thank you again.
You too.
Cheers, man. So I'm spotting an immediate issue here because we're getting obj.distance 15. So it looks like it's adding pointers to our object rather than duplicating the object. So we need to create a new object every time. Like so. Then we need to clear the object out once we've added it. Is that going to work? Really just trying to work out how this will work. So now, if those are unique objects, I should just get 12 rather than 15.
Yes.
Sweet. So I have to create a new object every time before I append it, or I end it with pointers. So this should be 10. Yay! Thank you. Thank you. Oh, 1 bit. How you doing, man? Yeah, cool. Oh, man, honestly, I'm so excited. I wondered how it did this sort of thing. If I can start playing with objects now, with code. I know you do all this magic where you're actually utilizing your tree for all your objects. I'm just, I just can't get my head around it. I'm slowly getting there, and I'm seeing how efficient. It's like, it's so slick what you're doing. But I find I've got a big disconnect between my scene tree and my scripting. And my brain wants to think linearly. It just wants to create, like, I don't know, I just want to see an object in my virtual mind, do stuff to it like this. And the fact I can do that is so cool. I love it. Right. Okay, cool. So now if that works, then I can start creating my loop. But it's now 5 to 10, and I'm going to finish at 10 o'clock tonight. I need an early night, so let's see what I can do in 10 minutes. 5 minutes. So, okay, so I want to loop through, create a list of all locations. So I want to loop through every location in the game.
I'll probably be doing something similar in tomorrow's stream.
Oh, cool. What are you going to do? Pathfinding? Oh, nice. I don't know what's going on with this stream today. I don't know what's going on with my internet connection. It was actually a bit bad when I was streaming yesterday. I was getting
For my 2D adventure game plugin.
yeah. Oh, I love her pronunciation of plugin. Let me just see. I'm just going to show you what I was seeing. I don't know if this will do it. Where is it? Oh, here. Yeah, look. 720p, 60 frames per second. First of all, you could save yourself a bit of bandwidth. You don't need to stream at 60 frames per second, or maybe it's good to. I don't know. I'm not. I'm streaming at 30. But it was like my bandwidth wasn't enough to cope with 720p at 60 frames per second, and so it was just pausing for ages and spinning. Seems to be working fine now. It was just sitting there like this over and over again. Let's just check my stream, see if it's the same. How do I look at my stream? Channel. Yeah, there we go. My stream, looking at your stream, looking at my stream. Settings. Oh, jeez. Mine's even worse. 1080p. My God.
Okay, I'll check. Not even sure where I can set it yet.
Yeah. Oh, well, look at that. Yeah. I'm sure, like, if I look at someone else, one of these other guys, I don't know where to set. I mean, I'm totally new to this stuff. So if I look at this, yeah, look. So this stream this guy's giving has given me the options, and so when it's on auto, it balances the stream based on the bandwidth they've got, and gives you is video buffering. Use the low latency toggle under the advanced settings. I didn't even have that option with your stream, and I was buffering. So it looks like I need to do the same thing. So I don't know how we do that. Maybe you need like some sort of special capture card. Maybe it's just settings in OBS. I don't know. Let me add that to my list. Check rendering resolution options for Twitch. How do we get downscale during live stream? I reckon it's probably you need one of those like an Elgato streaming cards or something like that, which I'm not going to go out and rush out and buy anytime soon, but it could be that you need something like that. Yeah. Low latency technology. Maybe. I would imagine that because that would give it, I don't know, be better at like creating multiple streams. I thought Twitch would do it for you though. So anyway, there you go. So I'm going to do one thing in the next 1 minute, and that is I want to just loop through my locations. So for in fact, I already do it, right? I think if I just search loop through locations, right? It's going to be in game if I do it at all. This loops through my. I basically want to do this. And I want to get all the objects in my game tree. It'd be nice if I could just select a group of type location. Can I do that? Have you used groups at all one bit? This is not a practical way of doing it, because I want this group to appear. See, at the moment I don't need to use it because I'm doing it programmatically here. Get nodes in group objects. That's awesome, because I don't have to filter through my entire tree, getting every bloody node. I did look at assigning the group in the code. I just could not work out how to do it. Every time I did it, it crashed.
Yes, I use groups.
So see when I create an object here of location, how can I set a group here so that every location instance I create automatically belongs to a group? Is there a way to do that? Or is it only when it's in the scene tree that it can belong to a group? Or maybe I add it to...
Call get underscore tree, dot add underscore to underscore group, group
nice.
underscore name.
In the ready function? I'm pretty sure last time I did this, I had some mega crash. Let's try it. Oh, let's get rid of that. Oops. Non-existent function add to group in base scene tree. Get tree, get current scene. And that's what I need to do. Hey. Ooh. All right, so if I look at a location object now.
Wait, let me check my own code.
Oh, cool. Thanks, man. That'd be handy. I love the AI walking around the place. It's awesome. So whilst 1-bit Godot is checking that, I'm going to just assume that he's going to come up with the goods there. If he comes up with the goods, then we can just do this.
Add underscore to underscore group is a node function, so you can call it directly.
Let's have a look. Where am I? Location node. Closed it. Add to group is a node function, so you can call it directly. Oh, right. Gotcha. Uh-huh. Well, maybe that's why it wasn't working last time. It's the last time I tried to do it. Okay, cool. So now I should be able to look at a location, check the node. See, it doesn't show as belonging to any group in my inspector here. If I go to remote, look at balcony. Will it tell me what group it belongs to, or does it not really provide me that info? Okay, well look, let's assume that's working.
You either set it using inspector or write code.
Yeah, cool. Well, okay, so we've got it on the onReady, so every object should now belong to this group, locations. Right, so I'm going to step through and print out print locations dot name. So that should give me all my locations now. Come on, I'm just going to turn off this debugging here. Don't need it right now. I'm really looking forward to trying to stop my AI from going in the lift if the lift isn't at the right floor. I knew I should have created a lift object rather as a sub location object rather than trying to make locations be lifts. Where is it? Global. Pathfinding, debug, off, play. Here we go. Right. Doing anything yet? Has been here for. Should not be spitting out at the moment. That needs to be in my debug. Where's my debug code? Okay. So, my pathfind, yeah, it should be spitting out all the time. So I should just get a list of location names, but I'm not. I'm not getting anything at the moment.
Do it in _enter_tree. Function is better and use remove _ from _ group it in _exit _tree.
Okay. So location. I've not heard of that hook before. _enter tree. Super. And use remove from group in exit tree. Okay. It should never be deleted as a either way, but it's nice and tidy. Okay. Right. So, do I need to? Yeah. Do I still need to pass the remove from group? Yeah, makes sense. Okay. Super. Let's try that. Yep. Nope. Not getting anything. Weird. Locations. Oh, God's sake. Am I helping?
Location, not locations.
Yay! Oh, thanks, man. Oh, yes. All hail, 1-bit Godot. Thank you very much, dude. That's awesome. Oh, my God. Right, I am all ready to implement Dijkstra now. I am confident that Friday night will be the night that I manage to implement. Well, I'm going to watch your stream and see if I can get some extra hints. Are you going to actually implement some pathfinding tomorrow then with your 2D adventure plugin? All right, it's just a note so I remember where I'm at. I don't know why my font's gone blue. Oh man, I'm so excited. Brilliant. In fact, I need a fanfare for you. That is just, I need a better fanfare for sure. What's this one do? Is it 4? Oh,
Watch out!
no, that's definitely not it.
Pathfinding is not primary object since no RE is required yet.
Cool. I have no idea what to expect from your 2D stuff, mate, but I can't wait to see it. Well, look, it's 10 past 10, so it's just a short one for me tonight. I wish I could carry on, but I've got to get an early night. I'm really been absolutely so tired I could barely get up in the morning, so I'm going to call it night. Thanks, 1-bit Godot, as always, man,
I need
for
to
your
go
help.
as well.
Cool. Thanks for joining me. I appreciate your help. And to White Carlson for your help as well. And have a good night, guys. Take care.
Good
and
night.
see you tomorrow. Cheers, dude. See you, man.